Okay, let's dive right into this. Welcome, everyone. Today we're demystifying a piece of technology we literally use every single day, the internet. In this explainer, we're going to break down the invisible architecture that powers our modern world. We'll go step by step through the actual building blocks of global connectivity.
But first, before we even talk about wires and signals, I want you to think about this. Is the internet the exact same thing as the World Wide Web? We all use those terms interchangeably, right? But are they actually identical? Keep that in the back of your mind, because by the end of this short explainer, you're going to know the definitive answer.
All right, to understand the whole globe, we really have to start at the very bottom. We just need two machines talking to each other. That's a network. Simply put, it's a group of two or more computers connected to allow communication between them. It's absolutely the foundational building block for everything else we're covering today. Now, when we take that network concept and apply it to a single room or a building, we get a local area network, or what we call a LAN. Picture your home office setup. A LAN interconnects those computers that are located right near one another so they can share files or, talk to a printer. It's just a localized web of communication.
But what happens if we zoom out? Well, if we go beyond a single building, we get a wide area network, a WAN. This kind of network is spaced over a much wider geographical area. Think about a college connecting computers across multiple different campuses. So we're basically scaling up here, right? From a single room with a LAN to a massive campus with a WAN.
So how do these machines actually interact with one another? Usually it's a setup using servers and clients. The server's main role is to exchange information between the computers on the network. The clients, on the other hand, are the computers connecting to that network via the server. Actually, if you think about it, whatever device you're using to listen to this explainer right now, your phone, your laptop, it's acting as a client.
Moving right along, how do our actual homes physically connect to these networks? Well, the most common hardwired method is broadband. And there are a few ways to do this. There's DSL, which uses specific digital telephone lines. There's cable, which cleverly uses existing TV lines along with the modem. And then there's fiber optic, which literally transmits information as light rather than electricity. It's incredibly fast.
Of course, we don't always want to be tethered to a wall, and that is where Wi-Fi steps in. By using wireless technology and a router, we can broadcast that hardwired broadband connection right through the air. This is what lets our devices connect seamlessly in homes, apartments, college dorms, and businesses.
But what if you're away from a router altogether? Well, cellular connections let us access the network while we're completely on the go. By utilizing your phone's data plan, you can even create a hotspot. That essentially turns your phone into a temporary wireless access point, connecting other computers and devices right to the network.
Now, there are times when traditional ground cables just can't reach highly rural areas. In those cases, satellite internet is absolutely vital. It does require a satellite dish and a modem installed at the home, but it completely solves that geographical distance problem by bouncing the connection straight down from space.
And then, there's dial-up. It uses a regular telephone line. It is notorious for its prolonged connection time, which really slows down the upload and download of large files like images and video. Today, very few U.S. households still use it. It's incredibly uncommon, but it stubbornly remains an option in places where modern internet infrastructure is just completely absent.
So the crucial point here is that all of these connection methods we just talked about, they're supplied by an internet service provider, or an ISP. This is the company providing your home connection. Big names like Comcast or Xfinity, Spectrum, CenturyLink, they essentially act as the gatekeepers, holding the keys to the infrastructure.
Okay, this brings us right back to our opening question. Are the internet and the World Wide Web exactly the same thing? The answer is no. No, they're not. The internet is the vast global network of physical computers. The World Wide Web, or just the web, is one specific way to send and receive information over that network. To put it simply, the internet is the physical roads. The web is the delivery trucks driving on them. And how do those trucks operate? Well, the web relies heavily on hypertext, or HTML. HTML is a system that links various objects to one another on the web. Things like text, images, and videos. Basically, it's the glue holding our entire visual internet experience together. You interact with this all the time. Every time you encounter a hyperlink, you're using this system. Those are typically the underlined, colored, or specially formatted text on a web page. When you click them, they seamlessly connect you to related content, whether it's on the exact same website or a completely different one sitting on a server halfway across the world.
It really does feel like magic sometimes, doesn't it?
But the next time you click a simple hyperlink, I want you to picture the vast physical network of servers making it all possible. The LANs, the WANs, the fiber optic pulses of light, all working together behind the scenes in just a fraction of a second. It's a true monument of human engineering. Thanks so much for joining me for this explainer, and keep exploring.